Hello all, my name is Sakil Ansari and I am a data scientist. Today I am going to start a new playlist, Logistic Regression from scratch. So basically in this playlist there will be around 5 to 6 videos. So in first 2 or 3 videos I will be explaining the theoretical parts regarding logistic regression, and in the last 2 or 3 videos I will be explaining the implementation part by taking a use case, and at last I will be deploying the logistic regression model at Hugging Face. So this is the end-to-end implementation of logistic regression. And let's start. And first of all, I would like to thank Harika. She has written a wonderful blog regarding logistic regression. So let's start. So basically, what is logistic regression? So logistic regression is a supervised machine learning algorithm that can be used to model the probability of a certain class of events. So basically, uh, we have supervised machine learning. So in supervised machine learning, we have regression and classification. So logistic regression comes under classification, and mainly logistic regression can be used for binary classification, but it can be used for multiple classification problem as well. So now see here. So basically there are two types of logistic regression. So as we have in linear regression, simple linear regression and multiple linear regression. In the similar way, logistic regression are of two types. One is simple uh, simple logistic regression, where we have only one independent features. In multiple logistic regression, we have basically more than one independent feature and one target feature. And there is some extended version of logistic regression. So you can see here. You can see here. Yeah, we have this multinomial logistic regression. So what does multinomial logistic regression mean? So basically, in this type of logistic regression, there is no ordering. Okay, let's say we have food vector. So we cannot order crunchy, mushy, crispy. In the similar manner, we have hair color. So we cannot order the hair color. Okay, so this is the type of logistic regression, and that is called multinomial logistic regression. And other one is ordered logistic regression. So in ordered logistic regression, we can order the outputs, like you can see here, customer rating, like dislike, extremely dislike, income level, like low income, middle income, high income. So this is the ordered logistic regression. Now we'll be explaining what are the limitations of regression. Let's say if you are using linear regression for classification, then what are the limitations? So I will be explaining that part here. So let's say, so you can see here, so this is a best fit line. Okay, so the equation is y is equal to mx plus c. Okay, so now see here we have data points, and let's say this is a binary class problem. So one class is 0 and other class is 1. So let's suppose I am giving a threshold t is equal to 0.5. Okay, and let's say if our predicted value is greater than or equal to 0.5, then that value belongs to our class 1. And if the predicted value by the model is smaller than 0.5, then that value belongs to class 0. So let's consider this 4 scenario. So in first scenario, you can see the predicted value by the model is 0.2, which is less than uh, which is less than 0.5. So it belongs to class 0. In other case, the predicted value by the model is 0.6, which is greater than our threshold, that is 0.5. So it belongs to class 1. Now in scenario 3, in case 3, the predicted value for the point x3 is beyond 1. Okay, consider this one, it belongs to 1. And in case 4, the predicted value for the point x4 is below 0. So now see here, we have only two class. Okay, we have only two class, and the value is between 0 to 1 in this range only. Okay, so for us, if any value which falls above then this range, then that value doesn't make sense for us, because probability lies between 0 and 1. Okay, and in the similar way, you can see here our x4 predicted value is 0, below 0, then it doesn't make sense for us. Okay, so this is the limitation for linear regression when we apply linear regression to classification problem. So now other scenario I would like to discuss. Let's say we had a data set and we added some outliers in the data set. And after adding some outlier, you can see here our best fit line initially L1, and it becomes now L2. Okay, so so you can see here. So what you can see here from this diagram, and you can also see here, like there are some misclassified points, right? These are some misclassified. So what you can see is, like, while adding some outlier to the data set, we are getting more errors. So this is another limitation of linear regression while using for classification tasks. So basically, in nutshell, we can say that there are two limitations for linear regression while using for classification problem. The first one is the predicted value may exceed the range 0, 1, and the other one is error rate increases if the data has outliers. So these are the two limitations. And in the next video, I'm going to explain the remaining parts. And this is it for this video. Thank you and happy learning.